Hello, and thank you for giving me the opportunity to talk to you about our study of fatigue in multiple sclerosis. Multiple sclerosis, or MS, is a chronic inflammatory condition of the central nervous system, and it is the main cause of non-traumatic disability in the younger population. With the advent of effective disease-modifying treatment, fatigue has been highlighted as one of the main the most disabling symptoms in this population. And because the pathophysiology is not fully understood, there are no effective treatment for this symptom. The purpose of this study was to investigate the origins of MS fatigue by combining neurophysiological techniques and MRI. The idea was to adapt existing protocols to measure neuromuscular fatigue in athletes and people experiencing exercise, and to combine them with the functional MRI to look at the brain areas that activated during a fatiguing task. The pilot study conducted in healthy controls was funded by CRMD. There are several theories on the origin of MS fatigue, but most of them involve areas such as the anterior cingulate cortex and the insular cortex, which are thought to play a pivotal role in the pathways that control fatigue. The connectivity between these brain regions is also thought to change or be modulated by fatigue. So one of the theories is that the brain damage caused by multiple sclerosis might reduce the connectivity between these areas and lead to increased neuromuscular fatigue. The study was quite complex and involved 2 sessions. We recruited so far 7 right-handed healthy volunteers. Unfortunately, we had to stop recruitment because of the pandemic. Everybody had a neurophysiological session where we combined transcranial magnetic stimulation and peripheral nerve stimulation to assess neuromuscular fatigue and performance. And then the same people had a functional MRI session. They had to perform a 2-minute maximal voluntary contraction of the elbow while we measured their performance, and also continuously asked them to rate their perception of fatigue and effort. The data that we collected were analyzed. I do not have time to go into the details, but I'm showing you the results of the fMRI part, where we found that during the fatiguing task there was an increased activity in the anterior cingulate cortex, but also in the left caudate nucleus and left prefrontal cortex. When we looked at the connectivity of the anterior cingulate cortex with the rest of the brain, we didn't find a coupling with the insular cortex as we expected, but with other regions such as the left middle temporal gyrus and the left precuneus. So it looks like the suggested conclusions are more complex than our original hypothesis, but they confirmed the role of the anterior cingulate cortex. We need to do more investigations, but also this pilot study highlighted the difficulty of performing the task that we chose in the MRI scanner without moving. So future work will look at reviewing this task and obviously at recruiting patients with multiple sclerosis as soon as this will become possible. Thank you very much.